Hey everybody, this is Larry. This is day 28 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. Remove end node from the end of list. I guess that is what it sounds like. Okay, let's see. For these farms, I think the idea is pretty straightforward, to be frank, or at least the understanding of it. Sorry, but mm, I think the thing that that's what I'm thinking about in my mind. I think the thing that I always worry about is just like off by one. But yeah, I think I think it's these kind of problems are always a little bit awkward. Both as partially as a someone who used to do competitive programming, only because I feel like even for competitive programming, these particular things don't come up that much. But within Leetcode's sphere, if you will, it does. There are patterns that or things that you kind of notice from time to time, and then you sort of kind of see how they apply to each problem and so forth. And of course, I would say these do come up on interviews from time to time. Though from what I hear, and I could be wrong, so definitely leave some comments in the comments. I've been seeing them or hearing about them less and less. So I don't know. Take that as you will. Let's say the first thing that I always do is just kind of declare a sentinel value. I call it new head. I don't know if that's a great name. Probably a terrible name actually. But yeah. And then the idea here is to get the nth node. Remember that we're not trying to get the nth node from the end. We're trying to get the node that points to the nth node to the end. So there are some possible off by ones there, but yeah, but I think the idea is like having this offset, right? This offset comes up a lot on these similar type of linked list farm. The other one is reversal, I guess, as you go from left to right. And from combination of those, you can do a lot of linear one pass time things. And because obviously, I guess the easy way to do it is with two pass. You just get the length of the list, and then you get, you could count n from that easily, right? Let's see if we could do it that way. But that said, to be honest, this one pass, two pass thing is a little bit awkward, only because if you have 2 pointers, like if you think about it in terms of efficiency and memory access, right? Well, now you're using, you're still accessing the memory in the same way twice, and I don't know that you always get cache locality with 2 pointers that are kind of offset from each other anyway, right? So in terms of performance, I don't know that would make that much of a difference, but conceptually it is a cool idea to think about, to have it in one pass instead of two. But yeah, okay, let's get so yeah, the offset idea is that in this case, well, if you have 1 point, you take n, which is not this n but n that goes to the end. So then you have, if you start one that's one off, then you get one from the end. If you start one that's two off, you get two to the end, and so forth. So I think that's maybe the idea, is that you have a fast node is equal to new head, slow is equal to new head, and then does n have to be smaller than the size of the list? Okay, and also size is 30. So I mean, I said all this stuff, and I also honestly, if I was in a competitive type timing, meaning trying to do this as fast as possible, but I just do it brute force because look, n is 30. Why spend too much time thinking about it? But yeah, so here we go so something like that, and then here now we have this offset. So while fast is not none, it may be fast dot next is not none. So like, I'm really lazy with the proving, but we'll see and kind of play with it. So fast is equal to fast dot next, slow is equal to slow dot next. And then at the very end, then maybe something like slow dot next is equal to slow dot next dot next, and then that's it. What are we returning? We return the head, new head of dot next, and that's basically the idea. Maybe off by one, but and also this should be okay if this is maybe not. Maybe I need to do this. That's what I mean by off by one. I wasn't sure, so I was gonna just try it out and kind of readjust that way, and that looks pretty good. Even removing the one node case, that's one of the case that I worry about. I think the only other case that I may think about is just removing the last node. So someone like this to 5, and also removing the first node. So yeah, let's try those. So those looks good. So I am going to be, wait, oh, I actually I think I got them both anyway, but I meant them incorrectly in that I thought I was trying to remove 5, but it's 5 from the right and so forth. In any case, it looks good, so let's give it a submit. And yes, score. Where's my pop-up? There we go. And here is our streak 911. Yeah, linear time, constant space, one pass kind of. So yeah, let me know what you think. Stay good, stay healthy, to good mental health. I don't have that much to add on this one. I think this pattern, if you do struggle with this one, this pattern does come up a lot. So I think, I wouldn't say memorize it, but try to understand why it works, how it works, and kind of understand, you know, how to kind of, how it applies to other problems and practice similar problems. This one comes up a bit. The other one that I think comes up a lot is reversing a linked list. And I think with a combination of those two, you get a lot of these problems. If you ask me, maybe not all of them for sure, but yeah, at least for linear time things. Okay, that's all I have with this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later. Let's hump over this week. Bye bye.